But you only need the light when it's burning low. Only miss the sun when it starts to snow. Only know you love her when you let her go. Only know you've been high when you're feeling low. Only hit the road when you're missing home. Only know you love her when you let her go. Staring at the ceiling in the dark. Same old empty feeling in your heart. 'Cause love comes slow and it goes so fast. When you see her when you fall asleep.
All right. Time for the next talk, one that I'm really curious about. One of my friends actually used to live on a street that had a number in her street name. And the system couldn't work with that. So she has some good stories if you want to talk to her. Marisha's there. But I'm very curious to hear what our next speaker, Philip Blair, is going to tell us about street names, normal names, and what problems you come across with that. So give him a big round of applause.
Thank you. So, my name is Philip Blair. I'm an AI consultant living here in Amsterdam. I focus on building NLP solutions for a variety of business problems for companies all over the place. And a topic that comes up a lot, and I've had the fortune to work with for many years, is names. So, fair warning, this is not going to be the most technical talk. We will discuss some Python solutions for working with names, but really the goal of this talk is to explain a bit more why names are interesting data in the first place, and hopefully help some of us think a little more about how we should try to integrate them into the things that we're building. So, growing up, I had a little bit of an identity crisis. So, if you can't tell from my voice, I'm American, and I have what is maybe the most Anglo-Saxon name ever, right? I've got first name, middle name, last name, and even a nice little suffix on there. Now, going through school, everything growing up, a lot of times my name would be misspelled with 2 L's and Philip, and frankly, that still happens a lot to me today. But, that was a pretty minor inconvenience, right? I mean, the name on my school transcript was slightly different, but it never really posed any practical issues for me. Then I got a little older, and I found that as my parents were no longer the ones filling in forms for me, it became a little confusing how I should be filling in some of these things that I come across. Whether it be for a website or applying for a passport, all of these types of things. Sometimes they want a middle initial separately. Sometimes I have to include it in the first name. Sometimes not at all. Sometimes they want the suffix on its own. Sometimes it yells at me if I give it the suffix. So as you can imagine, this became a little confusing. And then I moved abroad, and things got even worse. So the concept of suffixes is a bit foreign to the French. So I have been called Monsieur Blair Jr. before by somebody looking at my passport, which I thought was unique. And then separately, here in the Netherlands, when applying for health insurance, I got to figure out what 4 letters were. And I also got to figure out that I don't have any, and I'm going to mispronounce this, tussenvoegsel, maybe? Yeah, okay, I did okay. And of course, last name, we went ahead and just went with the junior, just for good measure. But, I don't mean to be so egotistical as to say that I have it the worst, right? I mean, as we're going to discuss in this talk, many people face many issues surrounding name validation across many different software applications and non-software applications, especially in the context of going abroad. And the reason why I felt this was an interesting talk to give today is because I think this is a really important subject that doesn't get enough attention. So, of course, COVID messed things up. But you can tell that the trend is pretty clear. Today, more people than ever are traveling to countries that they don't live in. And software that is built only for people in the country in which that software is built does not serve these people's needs. By being insensitive to their naming conventions, we are creating poor user experiences for these people. Okay, so first, I want to talk a bit about names. And specifically in this talk, we're going to be talking about personal names. there's a whole other subject we can get into surrounding organization names. I felt that was, first of all, we only have so much time together. But I also felt that that was a little specific because I think that's mostly relevant for people working in the finance industry and the government industries, things like that. So when talking about personal names, we can ask, as software developers, what is it that we're doing with names that we're given? Typically, we're doing one of two things. We're either parsing out the name into some sort of fixed schema that we want that name to fit into. Now, that could be done by some automatic process. That could be done by having different forms on the sign-up field, many different possibilities. But at the end of the day, the goal is to go from John Smith to first name John, last name Smith. Then separately, there's a number of applications where we're interested in comparing names. So you can imagine that for know your customer situations or for border screening, for example, you might have a list of names that you're interested in determining if somebody is on that list or not. And that is a whole separate problem to diagnose as apart from parsing names. But first, I want to drill down into this parsing idea. And again, parsing here could be something machine-generated, or it could be something manually done by users on your website. So if we take the name John Smith, we can create a nice little pydantic model. And I hope that the people in the back can somewhat read this. OK. So this model is meant to capture the schema that we expect these names to be able to fit into. And if you haven't used pydantic before, basically the way to read this is that we have two fields, and we first name and last name, and we expect them both to be strings. So John Smith, easy enough. But then, we can quickly find another example. I was a little less egotistical this time and went with somebody else who has the middle name and suffix. And we can see that, OK, that schema is not sufficient for fitting in this name. So we need to adjust it a bit. What we can do is we can add an optional field for a middle name, and we can add another optional field for a suffix. And then we can say, all right, maybe that's sufficient for names, at least in the Anglosphere. But then we can quickly break it. So if you grew up in the United States, you might recognize this name. I don't think this is a common song amongst European children, but there's just this children's song where you basically just sing about Mr. John Jacob Jingleheimer Schmidt over and over until your parents crash their car because you're driving them insane. Now, Mr. Schmidt, as we see, has two middle names. And if we think back to our schema, where we only have a string for a middle name, we have to ask, what is his middle name? Is it Jacob? Is it Jingleheimer? Is it Jacob space Jingleheimer? None of these answers are really satisfactory. So what we typically decide to do is, rather than distinguish between first names and middle names, we instead just say, OK, you have some number of first names. And so John, Jacob, and Jingleheimer will all be the first names of this person. OK, so schema's even getting a little simpler. That's great. And we actually find the same problem exists with last names, where certain people will have a surname that consists of two names. So based off of this, OK, we can make the same little change. Last name becomes a list of strings. And we can call it a day, right? We can say, all right, maybe we have the Anglosphere covered, which we don't, but we can pretend, right? But I think it's a lot easier to find examples of how this breaks when we go abroad. So just over the channel from England is this little country called France. You might have heard of it. And what you find in France is that, unlike in Anglo-Saxon cultures, where when somebody is married, they change their family name, or they leave it alone, but they either leave it alone or they change their family name to be the same as their spouse. In France, you actually retain your original family name throughout your life, generally speaking. And instead, you gain the ability to use an additional last name, which is that of your spouse. So what you can see here is that Gisèle Chevalier has the ability to use Dubois as an additional last name. OK, so she has two last names, but they're not two last names in the same way that David Lloyd George had two last names. So thinking about this a bit more, this isn't really workable inside of what we've built so far. But OK, for the French, we'll just add a new field, alternative last names. And it's same as last names, just you might have another one. Then continuing our tour around the European Union, we look at the president of Bulgaria. Now, his name, which I'm certainly going to butcher the pronunciation of, Rumen Radev, maybe, has what we call a patronymic. Now, this is a feature of many names in especially Eastern European countries, where this patronymic is neither really a middle name nor a last name, but really it's its own thing. And for those of you who are not familiar with it, this name essentially tells us that his father's name was Georg, or George, or I don't know the Bulgarian version of George, but whatever that is. So because of that, it doesn't really fit into any of the fields that we had defined thus far, meaning that, once again, we now have another exception that we have to account for in our schema. OK, let's go to Iceland. Bjork, you might know Bjork. So Icelandic names, Iceland's a very small country, right? And so typically, you can disambiguate everybody on the island by taking a first name and just the patronymic, and no real family name on top of that. Some people do have family names, but generally speaking, this is the traditional Icelandic naming convention. OK, so we can put it in the patronymic field, but then you might have noticed that thus far we've kind of had this invariant that last names always exist, right? So we have to decide, it's kind of a last name, but it's also not a last name. So where should it go? And that's just really the tip of the iceberg, right? We've talked about patronymics. There's also matronymics, where you get a name from your mother's side. You have countries like Indonesia, where some people only have one name, no last name whatsoever. You have, in certain cultures, like, for example, in certain sects of Judaism, you will be given an additional name in a time where maybe you're going through a severe illness, and this name is meant to give you God's protection. Is that another first name? Is that its own thing? Who knows? And then you have some cultures, like this tribe in, I don't have my speaker notes, so I don't have the name of the tribe, but there's a tribe in the Amazon where they don't have names. They just refer to everybody as like sister or brother. So what is that, right? Everything completely breaks down. And one thing you might have noticed is that we've all been looking at the same alphabet so far. So what happens when we go even a little further flung and we say, all right, for Leo Tolstoy, how do you write his name in English? Well, that's completely different than how you write it in French, even though ostensibly English and French have the same writing system. It's a whole can of worms. And finally, as we've said so far, parsing can either be done by a system automatically, or it can be done by asking a user to manually input something in a field. Well, you might think you're clever and say, all right, this seems complicated, so I'm just going to write an algorithm to do it. Well, good luck, right? Because you might have a name like this, where I bet whatever algorithm you wrote to parse names into first name, last name, et cetera, would probably screw this up and put Scott as a first name. OK. So I hope I've sold you on the fact that this is a challenging problem. So I want to take a step back and ask ourselves, why are we even doing this? What are we gaining from separating names in this way? So we can think first of a scenario where we would want to parse names. So when you book an airline ticket, why is the airline collecting your name? One of the primary reasons is because they take that name and they transmit it to, assuming this is an international flight, they transmit it to the government of the country that you're flying to basically check if everything's cool before you go. Now, governments have agreed on an international standard for what passports should look like. And so there's a very well-defined notion of given names, surnames. And we basically have all collectively agreed to shoehorn these naming conventions into this passport structure. And that is what these governments are using to do these checks. And therefore, it makes sense in this context to ask for what is in the given name slot of your passport, what is in the surname slot of your passport. Another situation which you might want to parse names, but the foundation becomes a little less defensible, is one in which you're trying to just standardize things internally within your product. So if you imagine that you're trying to, in this case, extend the behavior of your product to better support customers across, let's say, the United States and Russia, if you're not careful with the format in which you're proscribing users give you their name in, then you could create a very awkward user experience for one of those groups. So in this instance, due to a lack of prior research, because I guess let's assume that these are American developers, what we find is that the decisions that have been made at the product design level don't respect the needs of the users in this case, Russia. Now let's talk about a bad reason to parse, just because we feel like it, right? I mean, we just think, okay, there's a first name and a last name, so let's just ask for what the first name and the last name is. What we have here, and I'm sure that you can't read the fine print on this, is a shipping label from the United States Postal Service. Now, what you see if you look closely is that from the sender, it asks for their last name, their first name, and their middle initial, and for the addressee, the same thing. Why? I mean, there's no real reason why the post office needs this granularity of information of who is sending or receiving this package. And so all this is going to do is create confusion for situations where the recipient of this package or the sender of this package doesn't neatly fit into this first, middle, last name category. But now I want to take a little detour and discuss what solutions exist in Python for wrangling names. Now, it may very well be that in a lot of situations, and yes, I was egotistical and used my own name again for this, in a lot of situations, you may know, okay, the data that I happen to be working with in this situation is relatively well structured, more or less, and we know that the origin of the data is largely, let's say, Western European. So in instances like that, I would say that the package which, to my knowledge, is the best for working with names in this way is something called nominally. So it's a very simple package. It provides a couple of functions which are able to take a string, like the two that you see here, and parse them out into a structured representation of the name contained in that string. Now, the columns, essentially, that nominally is outputting here are fixed. And so you can see that in the second name here, many of them are empty strings, because there's no title in that name, there's no middle initial, and so on. But you can see in the first example here, it's able to parse this relatively complicated name that I put together. It's able to identify that E is the middle initial, which once again, middle initial is a little problematic, but we're going to have to live with it for now. And it also even identifies that Philip, in quotes here, is the nickname of this name. And so when thinking about how to use this, I mean, in reality, you're going to build some sort of tabular data store with those columns, perhaps something like Elasticsearch, where you can do a fuzzy match of these names and do a search that way. But just for illustrative purposes, I've just kind of thrown together a simple example here. So what this example is showing us is you can imagine creating a database of two names where you have John Smith and Smith Johnson. So suppose that our goal is to be able to search this database for a name. And specifically, we're interested here in looking for Smith, John. If you were to use a simple edit distance-based search where you take two strings and you kind of see how many differences there are between those strings and you score them that way, then we would erroneously pick out Smith Johnson as the correct match in this database because it's much closer to Smith, John. When we want our system to be a little smarter and see, okay, this comma here means that you should invert these things and do the match that way. So this search function is really just iterating through that database list. Let me see, does this have, it does have a pointer. We're just iterating through the database names, going through the different columns that get extracted from the nominally parser, and then just scoring the columns that we find in both the name that we give it at search time and the names that we parse during the database creation, and just computing the average similarity based off of those, which for John Smith and Smith Johnson would be a perfect similarity. So now, one thing that I've glossed over a little bit here is why is this idea of doing a fuzzy match so important? So in a lot of applications that work with names, the first instinct will be, oh, I'll just do an exact match, right? Especially like maybe if you're working with names coming from passports, you might think, okay, those are going to always be the same, right? Well, the problem is that when I go to the town hall here in Amsterdam and I tell them my name, they're going to type something into the computer. Who knows what they're going to type? They might type my name correctly. They might add an L. They might spell it the French way. Who knows? And in resilient systems, we want these things to be able to correctly identify those misspellings and account for them when doing a retrieval task. Now, what I've outlined here is a very basic solution to this problem. And unfortunately, once you get past this Western European basic context, open source solutions fall a little bit short. One thing we haven't discussed is the fact that in Chinese naming conventions, the last name typically goes before the first name. Additionally, because it's written in a separate writing script, you might have a situation where you have a name written in Chinese, a name written in English. You want to check if they're the same. Unless you have specialized software to do that, you're just not going to be able to. And there's a million paper cuts along the way in this problem, which is why really what I would have to recommend at the end of the day is to go with a commercial solution for those sorts of use cases. And those are really generally more in the KYC space or in the border screening space or in record linkage scenarios, like for health records. I've listed a few solutions here. Full disclosure, I used to work for Babel Street and built a solution that did this. But these are all, generally speaking, doing not the same, but similar approaches to this problem. But names aren't all we have in this world. So I recently took a trip to the US, and I went to go visit my grandmother. Typically what I do is I fly to Orlando, and I take a shuttle out to where she lives. And when I went to go book the shuttle the other week, I found this form, which for some reason asks where I live. I don't really know why they need to know that, because they're not taking me home, but they ask. Now, for those of you who live in the Netherlands, you might recognize this is the format of a Dutch postcode. This is the postcode for here, not my house. And that is very different than the format that you would have in the United States. And so, therefore, I was given a nice, friendly, I think this thing might be dying. Oh, there we go. I was given a nice, friendly error message as a result. So what are our addresses? Like, what do they look like? Because typically, we do need to have some sort of structured representation of an address in order to figure out, for example, for a delivery, like, what city is it in? What country is it in, right? So if we think about like where we are right now, it looks something like this. So we have our street name, followed by our house number, followed by our postcode, city, and country. Now, once you start looking abroad and thinking about differences of how addresses look, you quickly find that you have a lot of differences even here within Europe. So in Germanic countries like the Netherlands and Germany, you do typically have this street followed by, well, house number. This isn't a really big house, but you understand. House number format. Whereas in contrast, if you look at the Anglosphere or in France, it's typically the opposite. We would say 123 Main Street in the US. We wouldn't say Main Street 123. Similarly, postcodes are a nightmare. I mean, if you try to, as we saw a couple slides ago, constrain postcodes to fit really any sort of pattern, then that's going to be highly exclusive to the country that you're writing that pattern for, right? I mean, yes, there are many countries that share a similar format to the United States, but you also have more exotic formats like that in the United Kingdom. Canada is similar to the UK. Sometimes you just have different numbers of numbers. I believe putting the hyphen in the postcode is standard in Japan, but don't quote me on that. And I could go on. Additionally, if we think about the problem of saying, okay, well, fine. We don't want to validate each individual component. We just want to be able to take a string that represents an address, like if you're, say, getting something shipped to your house, and parse it out into its constituent components. It becomes a nightmare because in certain countries, we talked about how the house number and the street name can be switched around. You might also just have a complete inversion of the order in which things appear, right? So to make this a little more concrete, you can imagine if you were sending a letter to somebody in the United States, it might look something like this, right? You put their name, number, street name, city, state, zip code, country. In contrast, in Korea, you would do basically the opposite. The postcode still goes at the end, but everything else, you have the city name, which is both of these. You have the road followed by the number on the road, and then you have the name of the recipient, and then you have the postcode. So, completely different than what you would expect to see if your only conception of what addresses look like is what you've experienced living here in Europe. Now, similar to working with time zones, at the end of the day, the solution here is to just outsource the work to somebody else who's figured it out. So, what I would recommend is using a library called PyPostal, which is a wrapper around a C library called libpostal, which is specifically designed to solve this problem. This is just a quick and dirty example. This expand address functionality here is meant to do some normalization, but also create some different variants of the same address that are useful for indexing purposes if you're trying to do address search. But just to illustrate, we're just going to pull out one of them, and then we're going to parse it into its constituent pieces. And you see, if I give it both of those addresses that we just looked at, it correctly identifies that New York is the city, Seoul is the city, this is the house number, this is the house number, so on and so forth. So in this instance, I would strongly push you towards just using that rather than trying to figure this out yourself, because that is quite a task. Okay, so key takeaways that we can think about from this talk. So when interacting with any system, the most basic thing you can ask me is, what is my name? And if you make the user experience around that question complicated, then that's going to have a dramatic impact on the overall user experience that that person is going to have with using your application. And no, I'm not just talking about front end here, right? Because the schema choices that data developers make on the back end impact how those get represented in the front end. Similarly, a lot of these problems can be mitigated by really just focusing on the data that you need at the granularity that makes sense for what you're trying to do. If you don't need to know the street name separately from the house number, then don't ask me for it. Just ask me for my address. But whatever you do, especially with addresses, but also with names, do not rely on regular expressions if you are planning on doing anything international. Because the second that you open up your platform to data that comes from across your border, it's just going to fall apart. And when possible, if you can avoid parsing names and relying on strictly fuzzy search, then I would encourage you to do so highly. Before I wrap up, I do want to give a big shout out to Patrick McKenzie. Some of you may have seen this article that he wrote years ago called Falsehoods Programmers Believe About Names. I highly recommend that you give it a read because the issues that I discussed in this talk really only scratch the surface, and he has a lot of neat examples in there. I definitely took a lot of inspiration from this. So that's all I have to share with you today. I'm happy to take any questions. I do have both of these libraries loaded up if you have any specific demo questions that you want to grill it with. But yeah, that's all I have.
Okay, thank you so much, Philip. Any questions? Yeah, Marisha.
Let's say that you have about 1,000 attendees and you want them to pick up badges and you have different registration booths, how would you organize that?
It's an interesting hypothetical. So I think it's challenging because you do need to make a choice, right? I mean, you could say, all right, if you don't break up the names in any way, then that could still be confusing for maybe people from East Asia who might give you their last name first, right? But I think that the reality of the matter is that we are used to at least having a separation between given names and surnames, and I think that we can't change the world in that respect, and people are adapted to that. But really, I think what I'm trying to get at for a lot of those parts of the talk is really more just getting people thinking about this. And when you go beyond first and last name is where it gets really tricky.
I think we thought about this in the sense that we are in the Netherlands, and a lot of people have names like Van Beek, which are a little bit sort of differently in the Netherlands than they are abroad.
Yeah.
So that's why we decided to go for first name sort.
Makes sense.
And then I spent 2 hours telling people that it was sorted on first name, which was very confusing.
I know.
Thank
I
you.
walked up the beat when I got here.
Other questions? Yes.
Hi, thanks for the talk. So I was wondering if there is like any thought about a probabilistic or uncertain sort of interpretation to the fuzzy search part of it, because there are cultures where half a name could be shared by the whole culture, and then this has impacts on how many matches you return, and should an algorithm be reflecting how uncertain it's about a match or something like that.
Absolutely. So yes, that's definitely a problem I'm very familiar with, because when I said I had worked on software to do this, that was specifically what I was working on. Because yes, that's the hard part, right? Is if you are trying to check if somebody's on a sanctions list when they try to open an account in your bank. I mean, if they come from a country with a different writing script in general, there's going to be lots of different ways that name gets transliterated out into your alphabet. And so there are a variety of probabilistic approaches there. I didn't want to get into building your own here, but you can imagine things like hidden Markov models, or a few years ago I published a paper where we used a transformer for the task. But really the challenge is you need to have supervised training data for the language pair or for the script pair that you're interested in. And that can sometimes be a challenge to get, especially because there's usually a lot of noise in the real world. So.
Yeah.
So one, favorite talk of the conference for me, so thanks for that. Two, names are kind of messy because they come in all shapes and sizes, and addresses too. What other items might also kind of fit that category? I've always been aware that names are the trickiest thing out there, but lots of things have names. Are there any other sort of concerns that go beyond, what other fields in the form should we be worried about?
So I think that this is a problem that you're going to run into whenever you try to go from the unstructured world to any sort of structure, right? So I think names are a prime example because it's something that we can all relate to, especially, again, in a world where we're all traveling so much. But even just in general with doing document annotation, right? You can imagine that if you're trying to describe in some sort of structured sense what's contained inside of a document, there's probably going to be some sort of document that comes along that doesn't really fit the schema that you built around that. And so I think in general, at least retaining the original data before it's been structured in any way is prudent. Especially in names, but I think really broadly speaking across all forms of unstructured text.
Yeah, thank you for your talk. Very interesting to see all these cultures back in the names. I was wondering, I have a Chinese name, and there are, for example, very little surnames. And every time I type my surname, I think first 800 pages pop up with other people that are not me. Have you experience with handling this kind of stuff? Let's say, for example, also on a list, if you have to find your client, then it's not nice. It's on the 800 page. I would say.
Yeah.
Or if you find me on LinkedIn, for example.
I mean, typically, if you are constrained to only working with the Latin alphabet, especially, because of course, in Chinese, you'll have many different characters that get transcribed with the same two-letter character set in English. If you're constrained to working with Latin characters, then usually the best approach is to find some sort of other disambiguating information, right? So like, if you're talking about a passport, maybe like try to use the birthday somehow, and you can rule out, okay, maybe this 97-year-old person isn't you, for example. Yeah, it's a hard problem, especially because any sort of transliteration is inherently lossy. So you do lose a lot of information there.
Okay, thank you.
Yeah.
All right. Do we have time for one more question? I'm looking at my fellow volunteers. Yeah.
Thanks for the great talk. Actually, my question is a bit of a follow-up of his, because we had a same issue at our workplace, but we had the signatures of people. And do you have any experiences in matching signatures to find the correct person in a database, if you have all the signatures?
So by signatures, you mean like the physical pen on paper?
Yeah, the physical signature. And I didn't find a model out there. There was twin model approaches, but none of them worked out of the box, so I give up. But so far, yeah. Do you have experiences with that?
So I don't have experience with that. I mean, yeah, I think that multimodal NLP use cases like that are really interesting, but specifically for signatures, I don't have any experience with that, no. But it sounds really interesting, this problem.
All right, we are out of time, but I would like to thank Philip one more time. Give him one more round of applause, please.
Thank you.